Volume of cylinders, cones, and spheres. So just like when we looked at the rectangular prisms, triangular prisms, and square-based pyramids, we're going to investigate the faces of each of these shapes. So when we have a cylinder, so think a soup can, you have one rectangle, so that's the side. If I was to unfold this, I would get a rectangle. So if you think of a soup label, it's a rectangle. And we have two circles, one on the top and one on the bottom. When I looked at calculating the volume of a prism, whether that was a square-based pyramid prism, a rectangular prism, or a triangular prism, we looked at figuring out the area of our base, and then we times it by the height. We're going to do the same thing for a cylinder. So we're going to figure out the area of our base. So the area of a circle is pi r squared times the height of my prism, or in this case a cylinder, which is h. So the area of a circle, pi r squared, times the height of the cylinder. Now we're going to take a look at a cone. So if you have a party hat at home, you might want to deconstruct it to take a look at how you would actually create that cone shape. So the face of a cone actually includes one sector of a circle. And what I mean by a sector of a circle is it's just a portion of this circle. So if I was to draw a whole circle, it's just a portion of that. So it's not necessarily a quarter or a third, it's just a section of that circle. And if I was to fold that up, I would get this pointed cone shape. And then if I was to put a base on my party hat, the base of my cone is a circle. So if I wanted to figure out the volume of a cone, I can do a similar method when I looked at the volume of a rectangular prism versus the area of a pyramid. So if I was to say that these two shapes here, so I have a cylinder as my first shape, and I have a cone as my second shape. If my cylinder and my cone have the same radius and they have the same vertical height, and if I was to fill up this cone, let's say we're going to fill it up with ice cream, because why not? If I was to fill up this cone with ice cream, it would take me 3 cones of ice cream to fill up one cylinder, one carton of ice cream. So if the cone and the cylinder have the same radius and the same vertical height, it takes 3 cones to fill up one cylinder. So what that means for our volume is that I would take the area of my circle times the height of my cone or my cylinder, and then for my cone, I'm going to divide that formula by 3 to get the volume of the cone. So the volume of a cone is 1/3 of a cylinder. So if I come back here, the volume is pi r squared times height divided by 3. And the last 3-dimensional shape that we're going to look at in this lesson is a sphere. So the sphere only contains one curved shape. So there's nothing to actually create the shape in terms of different types of simple shapes. So the formula for the volume of a sphere is 4 pi r cubed divided by 3. So that's just a formula that you're going to have to refer to as you go through the volume. So let's take a look at some examples. In the first example, I have a cylinder. My cylinder has a radius of 11 centimeters and it has a vertical height of 14 centimeters. So the volume of a cylinder, I'm going to start by writing the formula, is pi r squared times h. I'm going to use 3.14 as the value for pi. My radius, I'm substituting in 11, so 11 squared, and my h, my height, I'm substituting in 14. Following order of operations, I have to calculate 11 squared first, so I have to do my exponents. 11 times 11 is 121. Then I'm going to also multiply that by 3.14 and 14. So the last step you can do in one full calculation, 3.14 times 121 times 14 gives us approximately 5,319 decimal 2 if I round to the nearest tenth, and my units are centimeters, and because it's volume, it's cubed. So the volume of my cylinder is 5,319 and 2/10 centimeters cubed. The next shape I have is a sphere. It has a diameter of 12, and because it has a diameter of 12 centimeters, I need to calculate the radius. So the radius is half of the diameter, or 12 divided by 2. So the radius of this is 6, and my units are centimeters. So sometimes you might have to do a quick calculation to calculate the radius if you're given the diameter. So the volume of my sphere is 4 pi r cubed divided by 3. So I'm going to do my substitutions. So 4 times 3.14 times 6 to the power of 3 divided by 3. I can multiply my first two numbers together in my numerator. 4 times 3.14 gives us 12.56. Now I'm going to calculate 6 to the power of 3, or 6 times 6 times 6, which is 216. And I'm going to divide this by 3. I'm going to simplify my numerator. So 216 times 12.56 gives us 2,712.96. I'm going to divide this by 3. Gives me a value of 904.3. If I keep one decimal place, my units are centimeters cubed. The next shape is my cone. My cone has a radius of 3 meters and a vertical height of 11 meters. The volume formula for a cone is pi r squared times h divided by 3. Substituting in the values for my variables gives me 3.14 times 3 squared times 11 divided by 3. I need to do exponents first, so 3.14 times 3 squared, which is 9, times 11 divided by 3. Let's simplify our numerators by multiplying my numbers together. 3.14 times 9 times 11 gives us 310.86. I'm going to divide this by 3, which gives me a final volume of my cone. Sorry about this. The volume of a cone of 103.6. I'm keeping only one decimal place, and my units are meters, in this case, meters cubed. Now, just like when we looked at the volume of a triangular prism or the volume of a pyramid, where we needed to do some additional calculations in order to solve for the volume using Pythagorean theorem, you may run into the same situation when we're looking at the volume of cones. So if I was to look at, this is an ice cream cone. The ice cream cone, it says, has a slant height of 13 centimeters. So when we looked at the slant height of a pyramid, it was that diagonal height. So the slant height of the cone is also the diagonal height. So it has a slant height of 13 centimeters, and it says the radius of the base of the cone is 5 centimeters. And we want to find the volume of the ice cream cone. So I know the answer, I just need to figure out how I get to that answer. So similar to what you did for the pyramid, or even the triangular prism, I want to just recreate just the triangular portion of this shape. So I have my right angle triangle. I'm going to redraw this so I can include my right angle in here. Okay, so I have my right angle triangle. Across my right angle is my 13 centimeters. And I have my radius of 5 centimeters up at the top. So I need to use Pythagorean theorem to solve for the height of my cone. So Pythagorean theorem says a squared plus b squared is equal to c squared. So I'm now going to relabel this triangle using the variables a, b, and c. Across from the right angle is c, the hypotenuse. I'm going to use 5 as my base, or my b, and I'm going to use a as my h. So substituting in the values from my triangle, I get h squared instead of a, plus 5 squared for b, and 13 squared for c. I have to calculate my exponents first. So h squared plus 25, 5 times 5, is equal to 169, or 13 squared. And now I want to get h by itself, so I have to get rid of the 25 on the left-hand side of my equal sign. Right now it's being added to the h squared, so I want to subtract the 25. And whatever I do to one side of my equation, I have to do to the other. So I'm going to subtract it from this side, so I also have to subtract it from that side. So it's gone from the left-hand side, so I'm just left with h squared. So I have h squared is equal to, and 169, take away 25, gives us 144. To go from h squared to h, I need to take the opposite of squaring a number, which is the square root of a number. And the square root of 144 is 12. My units in this question is centimeters. So now that I know that the height of my cone is 12 centimeters, I can now find the volume of ice cream that would fit inside just the cone portion of this. So I'm not going to worry about anything on top of the ice cream, of the cone, just what would fit inside of this cone. So the volume of a cone is pi r squared times h divided by 3. I'm going to substitute in my values for my variables. 3.14 times 5 squared times 12 divided by 3. I have to solve my exponents first. 5 squared is 25. Now I can simplify my numerators. 3.14 times 25 times 12 gives us 942. I'm going to divide this by 3 to give us 314. My units are centimeters cubed. And because this is a word problem, I need a therefore statement. So therefore, the volume of ice cream is 314 centimeters cubed.